Good morning. Okay, so today we got something kind of cool. I've been wanting to make this video for a little bit, but I had to get everything in order to do so. Um, so today we are going to, I'm going to show you how to make an ammeter. An ammeter is, you may, if you're into these videos and things, you may have seen one of these. These basically, this is a USB-C one. What it does is when you have a computer or anything else that does USB-C hooked to it, basically it gives you a readout of the power being consumed or used by the device itself. And just by that, you can tell a whole lot from it. Okay, so I'm going to show you an example. So if I plug this in, all right, let me show you this. If I plug this in like this, and nothing happens on the computer. I happen to know this one's kind of dead. Nothing happens, okay? And basically it's dead, but you have no idea why, where to go. You have no leads, okay? But by using an ammeter, what you do is plug it in. It's in line, basically. And basically what it shows you, it's hard to see, but it's taking 20 volts, which is good. Now, let me unplug it and show you what it does. It goes to 5 volts first, right? There you go. Then steps up to 20 volts. On this particular device, what that means is the USB-C controller is talking to the board, it's getting power, and then it says, okay, I need to turn on the power rail of 20 volts. But the difference with that on the bottom here is that it's only pulling, what is that, 175, flopping back and forth there, milliamps, and this should be several times that. So what this says is that it's there's a fault with the board. If this was working, we would see something different. With this one that does work, you'll see 20 volts, then what is that, 705 milliamps, 500 milliamps. That's like healthy. Then you open it up, it gets to turning on, and it's after a little bit it goes up to about 1 amp. It's going to be charging and whatnot, okay? But you don't know what's going on until you have an ammeter showing you these numbers to give you an idea of the problem that you could be looking at. Okay. Right, so another way it can help you, an ammeter, is let's say you plug something in and you end up getting a reading. It's not even turned on, no battery plugged into it, and you're getting a reading of something like 3 amps. Then that's obviously something pulling power. That means there's a short on the board almost certainly, which you can use a thermal camera like these, or I have a couple different ones, but a thermal camera, and you can see the short, fix the short, and you should have a working machine. So there's that too. Now, in my year or so journey to learn micro component repair and work at things on a chip level, component level, I've watched a couple different channels. A couple of them are just kind of fun to watch. A couple of them you really, really learn from. The two in particular I'll show you is Electronic Repair School, and the other one is Dell, what is it, Parts People, Dell Experts. That guy, he's very long-winded, but he actually shows you every step of the way. So watching these channels, on their screen there is an ammeter, okay? And while this one here is cool, it only works for USB-C connections, okay? So what happens if you have a Dell or an HP or something where you have a different kind of connection? And these guys, I'll show you, this is Electronic Repair School. He has one of these on his screen so he can see, the wattage that it's being pulled and amperage and volts. By the way, wattage is mathematically amps times volts makes watts. So if you got 2 volts or 2 amps with 20 volts, it's 40 watts. Anyway, that's just fun to know. Okay, so right, and then there's the Dell Experts parts people, and this is the one that kind of got me thinking I wanted to build this. Okay, he has one. They only deal with Dells, so the Dells are almost all the same exact one. If they're not USB-C, where you can use this one right here, then they are the barrel connectors, and then they have the smaller ones with an adapter. So that's super easy. But I wanted to build something where I could make it scalable. Like I could add different things to it. Like if I wanted to do a Lenovo or an Asus or an Acer or HP, all of these things, I wanted to put something together that I could add as time goes on. I could add more to it so that I could just plug it in, no matter the computer, and read off of the ammeter. That's what this is right here. Let me show you what I got here. This right here, it comes with this and one other major part called a shunt resistor. Here's a picture of what I ordered on Amazon. I think it was only like $15 or something like that. Okay, so basically, what's cool with this one, on the back, it actually has a schematic. Okay, I've already built this once in concept, so I know it works. But I wanted to build it in something really nice, so that I could put it on the wall, and then take this right here and run it around to my bench, so I could mount it to something like this. So on the wall, I built this to hang on the wall. This is the shunt resistor. Okay, for instance, the power comes in here, and we'll get into this in a second. But power comes in here and works its way to these two poles, negative and positive, and then through here, I wanted to take, like, let's say a Toshiba laptop connector, the end, and I run it through this little thing right here, and I attach it to the positive and negative like this. And these are bus bars, actually marine bus bars. So these will actually work up to, what is it? I don't know, 15, 20 devices, I guess. But I only really am going to need maybe like 4 or 5. So yeah, shouldn't be a problem. And then right through here comes the power, and I'll work on that. And then this right here, it's going to live in this little thing right here. And this will actually go to the bench with the screen, okay? And this will hook up through here. So we're actually going to go through the process using the schematic. I'll apologize in advance if one of those wires gets screwed up and I have to switch it. Just understand, this was my first time building one of these, and I was really super stoked when I got it to work. I did have to switch a wire, but I kind of know what I'm doing now. Okay, so what we're going to do is we're going to build this, and I'm going to try to put the schematic up on the screen, like maybe like up here somewhere, the whole time, if I can. That's going to basically be like an overlay so we can refer to it. Okay, so let me get ready and hang tight. Okay, so for this, I'm using a 200 or 130 watt Dell charger. I like these chargers. And also, strangely enough, Dell does weird things if you don't use a Dell charger. That's really the only one that I'm aware of off the top of my head that does that is Dell. So therefore, if I have a charger for a Dell powering this, then I should be able to use it for a Dell without it giving me a nag screen saying it doesn't recognize it. So what I'm going to do is I'm going to take all this together, and I'm going to kind of halfway do it just to plug it up so it works. Then I'm going to actually clean up all the wiring so it looks real nice and all of that. But I want to show you how to hook these up using this right here, which is the schematic on the back of it. And of course I got this 18 gauge 4-strand wire hooked to it to move wherever I want. I'll also put this keep this up on the screen on the top there so you can see it. and you can refer to that while I do this, so you can see, kind of see where I'm at. Okay, so the top one is a black wire, and according to our according to our schematic, this is going to go to this top one right here, the small screw. I'm not really well versed in the way these work exactly, but I can tell you that they do work. But there's something to do with this shunt resistor. At any rate, so the black one in my case is going to go to that top one. That is your small one here on top, and I'll like I say, I'll clean this up later. We just want to get it to work to show that it can. Actually, I'm going to do it the other way. Alrighty. Okay, there's that first one. Now, the second one, in my case, is the green wire, and that's going to go to the other small connector on this shunt resistor. Okay. Now let's do the bottom one, which is the red. This is going to go to the positive connection, which also goes to the load for the charger end, I guess you could say. So there you go. And I'm gonna set this up a little differently when all is said and done. But for now, this is how it's going to be. And here is the end that we're going to use right here. This is a Dell. It's actually the barrel jack with actually an adapter for the smaller one. So positive for this will go on this one right here. Okay, so that covers that one. The last one is the white one. Now, if you notice that this black one here goes through the outside of this right here, the larger ones. Okay, so what we're going to do is, let's see here. So we're following on the schematic. The DC in negative goes to the bottom large one here. Okay, so we'll just pop that in there like this. All right. And the top from the load, which is this right here, okay, goes to the other. Let me pop this out of the way here. All right, so the load, which is what's plugging in and pulling the current, is going to go to this other large one here. And again, we're just following the schematic provided on my particular one. Okay. Now, the white wire is the third one down, and that looks like it's also going to the bottom one of these two. Okay, so we're going to, okay, so we're going to go ahead and kind of clean this up a little bit. Both of these going into the bottom one here. All right, there you go. Okay, this is just temporary. I'll do everything else in just a moment, just to show concept here. So we have our screen here, and also what's cool about these Dell ones is that there's a little thing here that lights up when you have power. So when we plug this in, we want to see a blue screen with 19 volts or 20 volts, which we do, 19 volts with no draw. What this means is there's no power being pulled from this charger, okay? So I'm going to set this aside just for a second. I'd like to be able to set it so you can see it. Okay, there you go. That's better. All right. Now I'm going to grab some device and plug it in so you can see this work. Okay, here we go. I am plugging it into this laptop, and we should see some draw. Let me see. There we go. All right, so 1.24 amp. That's very likely that it's just charging the battery. If I turn it on, we'll see different things happen. Let me hit the power button. There we go. And you can just see several things change as it starts to boot up. See, it's up to 2 volt or 2 amps. It's pulling more power to start up the system and whatnot. Okay, and if I unplug it, it goes right back down. Okay, so that is the concept of what we did and showing that it's working. Okay, so now I've got everything tied up, zip tied and everything like I wanted it. I like to overuse zip ties, but it makes it so it's not going anywhere, none of the wires are going to come out. I will tighten these up a little bit before I'm done. But here is the whole point behind using bus bars. Okay, so here is the Dell end that I was using. Okay, so what I'm going to do is I'm going to plug this in now, and you'll see that the device comes on. Okay, and so here's the whole point of using these bus bars, is that I can run anything through these holes just to hold it, and then run them up to here. Okay, and anybody knows electronics knows that black is negative and red is positive. So I can take any one of these. Of course, I will put these on here using some connectors, like something like this right here, actual proper connectors. And then, because what I'm going to hook to this is going to be semi-permanent, but here's the cool thing, is that I can add, anytime I can add other ones. Like I can have a Lenovo end, then I can have a HP or old Acer. These are ones that have different ones. So now I plug it in, you see the light, kind of, right? And we can plug it in. I don't have the laptop here. Oh no, I do. Okay, just to show that it still works. So using the bus bar system, there you go. So you have a power supply that can power just about anything on your bench, and I can make a semi-permanent deal where I can run 5, 6, or 7 or whatever connections here to different laptops. And now we have a working ammeter, an inline ammeter, and I've got about 3 feet of cable here, so I can mount this with sticky tape anywhere I want to have it that's out of the way. And this right here, with this hole and this hole, I'll put 1 screw in each, and we will be to the wall, kind of stuck to the wall with this always live. So there you go, guys. I hope you enjoyed this and got something out of it. I took some time before I was really, honestly, comfortable making this device, but once I did, it was kind of nice, because it not only is nice and clean, but it serves the needs that I'm going to be using it for. And hopefully diagnosing computers is going to be even easier knowing the voltage that it's pulling. Okay, so that's it. Feel free to like and subscribe, and I really appreciate all support on the channel. Been out of it for a couple days, a couple weeks actually, but I'm going to ramp up some videos. I've got a few things in the works. Have a great day, folks, and if you do build one of these, leave me a, I don't know if you can put a picture in the comment, but leave a note in the comments if you try to build one of these, and hopefully you will have some good luck. Okay, have a great day. See ya.